Yeah, we are continuing the session regarding the reference electrodes. In the previous session, our student has explained some sort of ideas regarding the standard hydrogen electrode, which we called as a primary reference electrode. And now, as a continuation, we are doing with another reference electrode. We call it as secondary reference electrode, particularly Calomel electrode. The major difference I have to say is the standard hydrogen electrode produces 0 watt, but it produces different watts based on the different concentration. So this is the most widely used electrode. So I invite our students to continue with the explanation regarding this.
Hello everyone, I am Sasmita from the Department of Artificial Intelligence and Data Science. I am going to talk about the construction of the Calomel electrode. So it usually consists of a glass tube and the bottom is filled with the mercury, above which the mercurous chloride is placed. The remaining part of the glass tube is filled with a saturated solution of KCl. It also consists of a platinum wire which is sealed at the bottom, and the side tube is made to have a contact with the salt bed. So this is the actual setup of the Calomel electrode. So it consists of mercury at the bottom, mercurous chloride is placed above it, and the remaining part is filled with a saturated solution of KCl.
I am Pooja. I am from Artificial Intelligence and Data Science Department. So I am going to explain about the anodic and cathodic reaction of the Calomel electrode. Basically, we know anodic reaction is the oxidation reaction and cathodic reaction is the redox reaction. By undergoing the oxidation reaction, 2Hg in a liquid state gets oxidized and gives 2Hg to 2+, and by losing the 2 electrons. As for the cathodic reaction, it is a gain of electrons. By undergoing plus 2 chloride, it gives us the mercurious chloride as the product. And the rest of the thing will be explained by Rahul. Thank you.
I am Rahul from AIS department. I am going to tell about electrode potential. Electrode potential depends on the activity of the chloride ion. Electrode potential increases with decrease in chloride activity. Change in electrode potential is based on hydrogen scale. 0.1 KCl gives 0.3338 volt. 1.08 KCl gives 0.2800 volt. Saturated KCl gives 0.242 volt.
Hello guys, I am Priyanka Dushan and we are going to explain the advantages of Calomel electrode.
Calomel electrode is a stable potential, which means it gives a reliable and continuously result. Then it is a non-polarizable. The Calomel electrode is non-polarizable when it cannot be affected by small current. It is a cost effective. The material used in Calomel electrode is like mercury and calomel, which is inexpensive.
The construction of the Calomel electrode is very easy to maintain and become effective.
Hello everyone, I am Nivedita Ramesh and Nandan from AD department. We are going to explain about the disadvantages of Calomel electrode. The Calomel electrode is very much sensitive and it is Hello everyone, I am Nivedita Ramesh and Nandan from AD department. We are going to explain about the disadvantages of Calomel electrode. The Calomel electrode is very sensitive to all temperatures because in high temperatures it can degrade. And the glass is very fragile, so it is difficult to handle and transport.
The mercury used here is very toxic. We need a special precautions for handling and disposal, and it also causes environmental and health hazards. Next, it is slow response time. It takes slow response time when compared to alternatives like silver chloride, Calomel electrode.
Thank you.
Thank you.
Okay, we are discussing about the Calomel electrode and their advantages and disadvantages and anode and cathode. This electrode is useful to many categories and very useful to students to explain about this property. And the first
So now our students has explained what is the Calomel electrode, how it is working, and a demo with the detailed description of the construction and the anode cathode reaction, and particularly how the electrode potential value changes based on the concentration, and advantages, disadvantages, and the limitations. So based on this, we can understand that apart from this hydrogen standard reference electrode, the secondary electrode has a wide application and more practicability in the laboratories. Thank you.